Hello everyone. In this video I am going to show a quick demo about broad phase discrete collision systems uh, commonly used in computer graphics. So I implemented three commonly used algorithms. One is uniform grid, second one is spatial hashing, third one is sweep and prune. Let's get started with the first one. Let's play the scene. So in my scene you can see different shapes. So I'm creating those using GPU instancing. So you can go to the shape manager and you can change the number, so those things will change, and you can change the size from the code. Basically I will show you later. uh, what we are going to see here in case of uniform grid, like let's turn on this visualization. So you will see, like, here to detect collision we are dividing the whole space into fixed size cells. So that's why it's called uniform grid, and then inside each cells we do the collision check. Like first we need to assign shapes or objects inside there based on their positions, and then we do collision check inside each of these cells. So that's the very high level idea for uniform grid. Let's move to the second one. By the way, like this width and height you can change from camera orthographic projection size here. So just to mention, let's go to the spatial hashing. So here you see, like, we are not using uniform grid. Instead what we do, uh, we use a hash function to map spatial cells coordinate to hash buckets. So you see those buckets are creating dynamically based on the object's position based on the object means these shapes position in space basically. So this is quite efficient if the objects are distributed unevenly. Here you can see, like, not the okay, these objects are dynamically moving, but they are not evenly distributed. It's kind of sparse distribution. So in that case, when we are using uniform grid, it's kind of we are wasting memory resources and computation. So in that case, like, this spatial hashing is quite efficient. Okay, let's move to the that's all about spatial hashing at very high level. Let's move to the third one, sorry, sweep and prune. So what we do here, we first, so by the way, like, these boxes are called bounding box, axis aligned bounding box. So the red color for dynamic object, green one is for static objects. And what we do here, we sort uh, these boxes along an axis. So here I am using x-axis basically, but you can choose any axis, I guess. And then only overlapping intervals are tested for collision. So when you project this bounding box along an axis, so then you check the which shapes bounding boxes are overlapping, and then you do the collision check. So this is, like, really efficient, the sweep and prune one. Okay, so this is so that's all about very high level overview of these three algorithms. I want to show you few more things. Let's stop this scene. We can make this scene quite interesting. Let's put some large number, then the scene will look way nicer. Let's put something, I don't know, circle count 200, triangle count, let's say 200, hexagon, let's say 150, and space square count, let's put a little bit more less, 20, because those are static shapes basically. So yeah, you can, let's make it 250, a little bit more. Okay, so you can play with numbers as long as you're as long as what is called like GPU instancing is working perfectly. So what we do now, we need to change the current shape size are pretty high, so we can change it from here, this save GPU manager. Let's put it 1, let's put it I don't know, 0.6 maybe, otherwise it would be too large. 0.6. Okay, so now we can play the scene again and we can see how the scene looks like. So let's play and you see it's really beautiful. So and then if you come here, I did not, so like let's put this, so I'm doing like very high level like comparison between these three algorithms in terms of frame rate. So if I turn it on, so I set like for 5 seconds, and for like it will cycle through each algorithm for 5 seconds and it will count number of collisions happening here. So you see this is the number we are getting, but again this is not perfect evaluation matrix, just to at high level to see how many collision is getting detected with those algorithms. And if I want to see, like as I mentioned before, like technically sweep and prune would be pretty fast in terms of FPS rate. It really depends on the scene distribution, how things are distributed. So let's do one more thing. We will do more collision check, and then we can test which algorithm is giving better frame rate. So that means that indirectly indicates efficiency. So let make scene again shapes bigger so that we see a lot of collisions. So 0.4, let's say 2.6 is pretty high, but anyway we are going to test it. So and then okay, the scene will look a little bit ugly, but okay, this is just for testing. Yeah, you see it's like it's a bit ugly, but anyway. So now if we look at this, so there are a lot of collision happening, and if you look at these numbers, let's go to sweep and prune. So you see like the frame rate sweep and prune is quite high compared to uniform grid and spatial hashing, because again the way algorithms work, it's quite efficient. Yeah, you can play with this the shape size and numbers, but anyway this is not very accurate estimation, but just to get a high level overview how these algorithms are working. Okay, so that's all I want to show it here, and thanks for watching. Bye.